For question 2 part A, we need to show that the two vectors P and Q are parallel in same direction. So we know that if U and V are parallel in same direction, we can write it as U equal to lambda V, where lambda should be a positive value since it is in the same direction. So we should be able to do the same thing for vector P and Q. So vector P is 2i minus 4j plus 4k. So I can write it as vector 2, negative 4, positive 4. And vector Q is I minus 2j plus 2k, which is 1 minus 2 plus 2. And we can actually see that vector P is actually vector Q times 2. So we can write it like this. This is vector P and it is actually 2 times vector Q, which is 1 minus 2 and positive 2. Because 2 times 1 is 2. 2 times negative 2 is negative 4. And 2 times 2 is 4. So this is vector P and it is equal to 2 times vector Q. And hence, since the constant, which is lambda, is positive 2, which is bigger than 0, this means that P and Q are parallel vectors in the same direction. For part B, we need to show that the vector P and R are parallel, but this time in the different direction. So this means that we can write it like U equal to lambda V, but this time lambda should be a negative value. So vector P is 2, negative 4 and 4. And the vector R is negative 6, 12 and negative 12. So if we try and see here, we can see that the vector R is actually triple the vector P. So we can write down the vector R, which is negative 6, 12 and negative 12. And it is actually negative 3 times 2, negative 4 and 4. Because negative 3 times 2 is negative 6. Negative 3 times negative 4 is 12. Negative 3 times 4 is negative 12. And we know that this is vector R, which is equal to negative 3 times 2, negative 4, 4, which is vector P. And hence, R is equal to negative 3P. So we can see that here, the constant is negative 3. So lambda is negative 3, which is less than 0. So if the constant is less than 0, this means that both of these vectors are parallel vectors, but in different direction. Now let's do example 2, question 1. We need to find the magnitude and unit vector for the vector A, which is 3i minus 4k. So note that in this vector, there's no unit vector j. So this is actually A equal to 3i plus 0j minus 4k. Therefore, we can write down the vector A as 3, 0 and negative 4. And thus, magnitude A is square root of 3 square plus 0 square plus negative 4 square, which is square root of 25, and hence the magnitude is 5. Therefore, the unit vector is A hat, where it is actually vector A divided by the magnitude. So we know that the vector A is this one, or you can just use the original, which is 3i minus 4k. And it is divided by the magnitude, which is 5. So you must not leave your answer like this. Just separate them. And hence the final answer is actually 3 over 5i minus 4 over 5k. So that's how you write the magnitude and unit vector for vector A. In the next part, we need to find vector B with 10 unit long in direction of vector A. So we need to find a new vector B, and it is 10 times longer than vector A. So say that I have vector A which is this long, and vector B will be 10 times of that. Okay, so what we're gonna do here is we're just gonna imagine that vector A is just one unit, so that it is easier for us to find vector B. Okay, so to do that, we need to use the unit vector A, because A hat is a vector of length 1 unit. Okay, therefore vector B is actually 10 times A hat. And we already know that A hat or unit vector A is this one. By simplifying, we can see that we have 2 times 3i minus 4k. Therefore, the final answer is 6i minus 8k. And that is the vector B.